Turning sewage into oil. When sewage arrives in a wastewater treatment plant, it goes through several processes to get rid of oil, grease, solids, and matter. The remaining waste that isn't separated is called sludge. It's a mix of hazardous materials such as heavy metals, antibiotics, steroids, endocrine disrupting chemicals, and plenty of other undesirable materials. When disposing of it, most of it is sold as fertilizer to farms, and the rest is sent to landfills. There isn't any scientific evidence on whether that practice is safe, but seems very controversial with all those hazardous materials going back into our food supply. With about 34 billion gallons of wastewater collectively going through treatment plants per year, there's a lot of sludge being produced. An alternative to landfill disposal and use as a fertilizer should definitely be sought after. Previously, sludge could have been anaerobically digested and dried to produce methane. However, drying it is usually energy intensive and costs lots of money, making it unfeasible when there are cheaper fuels available. According to research done by the Pacific Northwest National Laboratory's Department of Energy, they were able to mimic the Earth's natural fossil fuel formation process by a process called hydrothermal liquefaction. Instead of waiting millions of years for our oil to naturally form, this new process can convert the sludge in less than an hour. It works just like crude oil and can be processed and refined the same way. Drying also isn't necessary, like in pyrolysis to create methane. This makes saving energy a lot easier. Water is actually needed to perform this process, making sludge a great candidate. Hydrothermal liquefaction is done by pressurizing and heating the sludge in a tube at 3000 psi and 660 degrees Fahrenheit. These conditions would still keep the water in liquid phase according to the phase diagram. This type of hydrothermal conversion technology has come a long way through the years. Currently, it can convert 60% of the sludge into biocrude, and the remaining 40% into a liquid phase, which can be turned into other fuels with a catalyst. In the sludge are long chains of organic compounds. When the water is heated up, it dissociates to hydrogen and hydroxide, an acid and a base, making it easier to disintegrate and reform the organic compounds into short-chain hydrocarbons, also known as oil. First, dissociated hydroxide breaks away at certain linkages, allowing dissociated hydrogen to bond with them. Water is normally hydrophobic of oil at standard conditions. However, solvent properties change with temperature, so increasing the temperature of water to about 500 degrees Fahrenheit will match them to acetone's solvent properties at STP. Heating it to 660 degrees Fahrenheit just makes it a better solvent. This allows the dissociated hydrogen ions to react with the sludge. Hydrothermal liquefaction has many advantages to it. Sludge is renewable, and since we're not extracting it out of the ground, it has net zero emissions, meaning it does not contribute to the CO2 in the atmosphere, nor does it decrease it. There's no food versus fuel debate around this. We're literally taking food that has been already digested and turning it into energy we can reuse. True, it has been used as a fertilizer, but using sludge as a fertilizer itself is its own debate. Currently, it has the potential to produce 30 million extra barrels of oil a year. Each treatment plant can adopt this process and power their plants with the oil produced. This process also allows wastewater treatment plants to eliminate the cost and need to dry the sludge and transport it for disposal in a landfill or farms as a fertilizer. Instead, it'll even save energy costs needed to run the plant if the biocrude is burned to generate electricity.